Hi, in this video about the linear differential equation for grade GS and LS. This is a part 4 of a series of videos about differential equation. In this part, we will solve the exercise differential equation first order. Exercise 1. Given the differential equation E equal y prime minus y equal 2x ex. Suppose that y equal z ex. We give us a changement of variable, a new variable z to facilitate the differential equation. We ask us to find a differential equation E prime satisfied by z. So we have a differential equation E here satisfied by y. We ask us to find a differential equation E prime satisfied by z. Then to solve this differential equation E prime and deducing the general form of the differential equation E. Okay. And last part, we have to find a particular solution verifying a certain initial condition. So let me be clear here. We have a differential equation. Usually this differential equation is not easy. The teacher of the question give us a changement of variable to find another differential equation E prime. Usually E prime is more easy than E, and we can do it, we can solve it with our formulas, and it's easy to do it. When we find the general solution of E prime, it will be very easy to deduce the general solution of E. Okay, and after that we find the initial condition. First, before I start, let me precise this thing. Derivative of x is a variable in this case. The derivative of x is equal to 1. The derivative of y is equal y prime, not equal to 1, because y is a function of x. The derivative of z is equal z prime, because also we consider that z prime, z and y are function of x, and x is the variable. Okay. For example, if I have z squared, derivative of z squared, it's in the form u squared, and the derivative of u squared is 2u prime. So derivative of z squared is 2z into z prime. Okay, derivative of x squared, x is the variable, derivative of x squared is simply 2x. It's simply 2x. So now let us start our work. We have y equals z ex. We have to substitute here y in its place, in its value z ex, and y prime. We have to find y prime first. So y prime, this one is in the form u into v, and the derivative of u into v is equal u prime v. U prime is z prime, v derivative of ex is equal to ex, plus v prime u. V prime derivative of ex is equal ex times u is equal to z. So this one is u prime v plus u v prime, derivative of uv. Okay, then substituting in the equation E, we replace y prime by z prime ex plus z ex, and we have in place of y we put z ex. Simplify equal to x ex. Simplify z ex with z ex. So we get z prime ex equal to x ex. I simplify ex and ex here, can simplify ex and ex. So z prime equal to x. This one is very easy, is in the form y prime equal g of x, and to calculate the integral, it's simply to find the solution of this differential equation. It's simply we have to make the integral of this function is equal x squared plus c. Here, let me be clear a little bit. This one is the differential equation E prime. So this one is differential equation E prime. This one here is the general solution of E prime. Okay, why of E prime? Because we find here Z is the general solution of E prime. Why it's a general? Because containing a parameter C. Now we have to find the general solution of E. Very easy, we use this one, y equals ZEX. We have y equals ZEX, Z already, we calculate Z here, replace Z by its value here, x squared plus C times the X. Very easy to find y. This one, x squared plus C EX, is the general solution of the equation E. Why it's for the equation E? Simply because it's y. Y is the general solution of the equation E that's satisfied by y. Okay. Now we have to find the particular solution. It's very easy. We replace x by 0 and the value is equal to 1. Replace x by 0 here. So we get 0 plus c times e power 0 is equal to 1 equal 1 and c equal 1. This one here, when we replace c by 1, this one is a particular solution of E. It's not for E prime, it's for E because it's y. It's y. So it's very easy. You see here we have a differential equation. Difficult. We use a change of variable to get an differential equation very easy to solve. We find the general solution of this equation E prime, and to find the y, it's very easy. We replace z by the value. Y is the value that we find here. Okay, this one is the general solution of E, and we have the initial condition to find the particular solution of the equation E. Let me take another example. We have here a differential equation. This one is a differential equation E. Suppose here is given the change of variable all time given by the in the exercise or by the tutor or by a teacher. Okay, find differential equation E prime satisfied by Z. So we have to transform all the y and y prime here to Z and Z prime. After that, we get a differential equation. Usually it's more easy than this one. We solve it, the equation E prime. Okay, let me start to work this part. We have y equals z plus, here it's very easy, y equal z plus xex plus 1. Okay, calculate y prime because we need here y prime. Y prime equal derivative of z equals z prime, derivative of 1 0. This one is the form u times v. U prime is 1 times ex plus v prime, derivative of ex equal ex times x. So let me remember you that derivative of ex is equal to ex. Okay, now we have y prime. We replace y prime and y by the value, by their value here. So we get z prime plus x, this one to replace y prime, minus y, so minus z minus xex minus 1. Okay, don't forget we have minus ex plus 1 equal to 0. Now plus xex and minus xex we simplify, plus ex and minus x we simplify, minus 1 and the plus 1 we simplify, we get z prime minus z equals 0. You can see very clearly that this differential equation E prime satisfied by z prime is more easy than the differential equation E satisfied by y. To find the solution of this differential equation is very easy. We have the rule y prime plus ay equals 0, so y equals ce minus ax. So here sure it's not y, it's z. We have to put z equal So z equals cex. Okay, now this one is the general solution of the equation E prime satisfied by z. To find y, we ask us here to find the general solution of the equation E. Very easy. We have y equals z plus x ex plus 1. Simply replace z by its value here. So y equal, we replace z by cex plus x ex plus 1. And here we take ex common. Okay, this one is the general solution of the equation E. The general solution of the equation is satisfied by y. Okay, now we ask us to find a particular solution verifying y of 0 equals 0. This one is x and this one is y, the value of y. Okay, so we put y of 0 equals 0. The answer is equal to 0. We replace x by 0. E power 0 is equal to 1. So c equal minus 1. And now when we get c, we replace c by the value here, and we get x minus 1 ex plus 1. This one is the particular solution of the equation E or E prime. Sure is E because it's y. Y is the particular solution of E. What's the difference between, I remember you, what's the difference between general solution and particular solution? General solution containing constant of integration C. Particular solution is a fixed and given function verifying, satisfying a certain initial condition. Okay, let me take a third example. We have here xy prime plus 1 minus xex plus 3 equal to 0. Differential equation, difficult differential equation, let me say, defined by, satisfied by y. Suppose that z equal xy, the given change of variable by the teacher. We have to find the differential equation E prime satisfied by z and solve E prime. You know that after this video you can do all the exercise for GS and LS in official exams about first differential equation. Okay, now we have to calculate, we have to find first y. Y is equal z over x. Why we have to find why we have to find the value of y? Because we have to replace y by the value, and we have now to do y prime, the derivative. Okay, so y equals z over x. Y prime, this one is in the form u over v. Derivative of u over v equal u prime, so z prime v x minus v prime derivative of x1 times z over v squared x squared. So let me remember you that u over v all prime is equal to u prime v minus v prime u over v squared. So we get here x into this one is y prime plus 1 minus x y, so z over x equals 3. When we simplify here the x and the square, we get here z prime x over x, so z prime only, minus z over x, plus here we have z over x times 1, so z over x, minus x z over x. We simplify the x and the x, so we get minus z equal to 3. Now minus zx plus zx we simplify, so we have z prime minus z equal to 3. This differential equation, we know the general solution. It's ce minus ax plus k over a. Which one is a? A is this one minus 1, and k, this one is k, the constant after the equality, the second number. Okay, so z equals c. Y is z because the equation, differential equation is satisfied by z, so it's not y. The general solution is z. cex plus 3 over a is equal to minus 1. So this one is the general solution of the differential equation E prime. Okay, look is how much is easy to find the general solution of E. We don't have to do any work on differential equation. We have only to replace this Z by the value find here. So y equals z over x, z is equal this one over x, and this form is the general solution of E. Okay, now we have to find the particular solution whose curve cuts the x-axis at x equal ln of 3. So y of ln 3 equals 0. Replace x by ln 3 minus 3 over ln 3. E and ln are two inverse functions, so we simplify E and ln, we get 3c minus 3. Here we can put over 1, so only the numerator equals 0 and c equal 1. When we have the value of c, we replace c by the value here, and this one is the particular solution of the equation E. So I stop in this video here, because in the second video we will see the second order differential equation. Thank you to see this video.